Assalamualaikum and good day. My name is Fais bin Yusuf, and today I will explain for my final year project 2 on topic of experimental investigation on drilling of carbon fibers and aluminium stacks. And this is the overview for my presentation, starting from introduction and ending with conclusion. For today's presentation, will be focused on the methodology and result and discussion of finding for the experimental that have been done. And for the introduction, the stack up of this material combination of FYP and aluminium has been widely used, especially in aerospace industry. As can be seen, the picture show the part that have been made by combination of this stack up material. And the advantage of using this stack up material is it have a high strength to weight ratio that can give better performance for the aerospace product. There are two main problems while drilling this stack up of material. And first problem, it have a different property of material for CFRP and aluminium that make it hard to drill process. And also the drilling process of this stack up material will produce critical bore formation that is not acceptable in the aerospace industry, that highlight the importance of precise machining procedure. There are two objectives of this study. First is to fabricate drill bits with different point angle and helix angle that later will be used for this experimental study. And the second is to find the relationship between point angle, helix angle and cooling method that have been applied during the drilling process to the outcome of the project, that is to measure the whole dimension accuracy, the burr height and the shape of burr formation that occur on the drill hole. And this is the scope of this project, that consists of the material that will be used, the machining parameter, machine setup, and also the output response that will be studied on this experiment. Next, I will talk a little bit about the literature review that has been done before doing this experimental study. And this is the summarize of literature review that has been done by me from few researchers. As can be seen from the summary of the literature review, the cooling method and drill geometry that is being used during the drilling process have significant impact to the outcome of the experiment. And can be seen, most of the study use dry and flat cooling method during the drilling process of this stack up material. And for this experiment, we will try to compare the outcome of dry and MQL nanofluid method to the experimental outcome. For the methodology, it starts with defining the parameter of experiment, that is point angle, helix angle and cooling method. Then continue with design of experiment using Taguchi method to find the number of run that is needed for this experiment. After define the parameter and do the design of experiment, we found the drill geometry that need to be fabricated for this experiment based on the point angle and helix angle of the drill. So start the fabrication for the drill by making the fluting and do the pointing of the drill. And lastly, we will inspect the geometry of the drill, and it will achieve the objective one of the study, to fabricate different drill with point angle and helix angle. After that is the preparation of nanofluid by mixing palm oil and gum arabic as a surfactant and hexagonal boron nitride as the nanoparticle. This nanofluid have been prepared using ultrasonic homogenizer, and as can be seen on the slide, there is the parameter for the ultrasonic homogenizer uses, and the overall time for this mixing of nanofluid take about 35 minutes. Next, after the preparation of nanofluid, we can proceed with the drilling process for the experimental study. And from the table show the machining parameter that has been used for the spindle speed, feed rate and the flow rate for the MQL equipment. And the above picture shows the setup of experiment in the CNC 5-axis milling machine. For measurement of the output of the drilling process, this is the method that has been used to measure the output response. caliper wheel is being used to measure the hole dimension that is being produced on the entrance and the exit hole of the drill hole, while SEM is being used to capture the image for the burr formation on the entrance and exit hole. And lastly, image J software is being used to measure the burr height that has been produced using the image that has been captured using SEM machine. Next, I will proceed for chapter 4, result and discussion. This is the result for objective 1, that is fabrication of drill bit with different point angle and helix angle. The drill bit that has been fabricated earlier will be inspected using optical comparator to measure the point angle and helix angle of the drill. And from the outcome of the measurement, it shows that all the drill that has been produced is follow the requirement that is needed for the experimental study based on the number that has been measured on the point angle and the helix angle. And this is the summary for objective 2 for the hole dimension measurement, the type of burr formation, and also the burr height that has been recorded from the experimental study. And this is the summary for average value of hole dimension. As can be seen, the hole dimension varies from the drill diameter value, that is 6.35 mm. And from the value, we can be seen that the entrance hole have larger dimension compared to exit hole. And from the analysis that has been done, this shows the optimum parameter to get the best value for entrance hole and exit hole. And from the optimum parameter suggested, the differences between the two outcomes shows in terms of point angle. While for entrance hole, the best point angle to be used is 130 degree, while for exit hole, the best optimum point angle is 140 degree, while the cooling method and the helix angle same at using of MQL nanofluid cooling method and also at 10 degree helix angle. And based on analysis of variance, for entrance hole, the point angle, helix angle and cooling method does not have a really significant impact to the entrance hole dimension value, while on the exit hole, the significant parameter is helix angle and cooling method, while point angle does not really have a significant impact to the outcome of the hole dimension measurement. It can be seen based on the P value of the analysis of variance that helix angle and cooling method have value less than 0.05, while point angle has a larger value. It shows that the point angle does not have a really significant impact. And if comparison between entrance and exit hole, it is better to use the optimum parameter of exit hole for MQL cooling that use MQL cooling method, helix angle of 10 degree and also point angle of 140 degree to get the best value for the whole dimension. Next, I will proceed to explain on the burr formation that has been produced on the entrance and exit hole for this study. And this is result for run number 1. As we can see, the entrance hole does not have any burr formation, while for the exit hole there is non-uniform burr and also burr cap produced. This slide shows the burr formation for run number 2 and run number 3, and this is for burr formation for run number 4 and number 5, and this is for burr formation run number 6 and 7, and this is for run number 8, and finally for the run test of number 9. And as can be seen from previous slide, all the entrance holes of the drill process does not show any burr formation on the entrance hole, while for the exit hole there is 3 types of burr formation. There is non-uniform burr with burr cap, uniform burr with burr cap, and uniform burr with no cap. And for the entrance hole, there is no burr formation due to the laminated of woven epoxy on top of the CFRP that reduce the lamination process that make it no burr formation on the entrance hole. And for the exit hole, it shows that the burr formation have significantly affected based on the point angle value. As we can see from the earliest slide, for point angle 120 degree, the burr formation is non-uniform and also quite big compared with the other run test that is using higher point angle value such as 130 and 140 degree. And also after point angle, you can see that the cooling method also affect the type of burr height that produced on the exit hole. And finally, it followed by helix angle. From the image of burr formation that has been shown earlier, the analysis for burr height is only being done on the exit hole because the entrance hole does not have any burr formation. And the analysis of burr height support the finding of the burr formation that shows the point angle have really significant impact to the type of burr formation and also the burr height value. And as we can see from the data of analysis, based on the analysis that is being done, the analysis suggested that higher point angle value at 140 degree will produce smaller burr height value. And to minimize the burr formation, it is suggested also to use MQL nanofluid cooling method and 10 degree helix angle. And next, this data is being supported by analysis of variance that shows the p-value of point angle is smaller than 0.05 compared to other two factor, that is cooling method and helix angle, that have p-value larger than 0.05. This p-value shows that the point angle have a really significant impact to the burr height value on the exit hole. And based on the chart on the slide, the burr height is significantly decreased when the point angle of the drill bit is increased at 140 degree. And also the helix angle have a minimum impact to the burr height value. As we can see, the burr height is slightly lower for the smaller helix angle at 10 degree compared to higher helix angle at 30 degree of point angle value. For conclusion, the first point is the drill fabricated with different geometry of point angle and helix angle have a really significant impact to the outcome of this experiment. Next is to get the best value for hole dimension. Helix angle is the most important factor compared with the other two factors. Next is MQL nanofluid is the best cooling method compared with dry machining and MQL based fluid to produce a hole dimension accuracy and smaller burr formation of drilling process. Next point is point angle is the most significant factor, followed by cooling method, then helix angle that affecting the burr formation at the drill hole. Finally, increasing point angle will reduce the burr formation and also the burr height, and also reduce the helix angle will produce smaller burr height on the exit hole of the drill hole. That's all from me. Thank you.